Hello, this question is a probability and z-scores in normal distribution. Okay, let's have a look at the question. A random variable is normally distributed with a mean 0 and standard deviation 1. The table gives the probability that this random variable lies between negative z and z for different values of z. The probability values given in the table for different values of z are represented by the shaded area in the diagram beside the table. So this is the table, this is the bell curve. What does that really mean? It means between the two z-scores, the shaded part is the area, which is the probability. Now they are symmetrical, so from negative z to 0 and 0 to z are the same. So for example, if I'm looking at 0.25 as my z-score, negative 0.25 and 0.25, and that is representing by probability 0.1974. So this whole thing is the 0.1974. Let's have a look at the question. Part A, using the table over here, determine the probability that this random variable will lie between z equals minus 0.5 and z equals 1.25. I need to sketch about 3 bell curve diagrams to explain this situation. So the first bell curve, z-score is minus 0.5, minus 0.5. And the symmetrical side is 0.5. So we're looking at the area in between those two z-scores. So this is represented on here, and our area, which is a probability, is 0.3829. So that was z-score is a negative 0.5. Okay, we can't just jump into the negative 0.5 to 1.25 because they're symmetrical. We have to go one at a time. So second bell curve, negative 1.25 to 1.25. Obviously, the mean is a 0 in the here. So here, my probability represents the area of between these two z-scores. Okay, so if I combine this together, because it said between them, it's not whole thing combined. I need to be very clever about this. 0.5, and then I'm going to go to 1.25. Oops. So the area I'm looking at is this. This is the probability that I'm looking for. So when you look at this, you can tell that my probability is half of z-score 0.5, which is this part, A, I'm going to call it A, and then half of my z-score is 1.25. I'm going to call this as a B. So this is my half of when it was, z-score was 0.5. Okay, so I have to halve that. And this part is the half of 1.25. So this z-score and the probability is actually full area, but it's only half of it. So finding a probability of between minus 0.5 and 1.25 equals half of the negative 0.5 and 0.5. The first one, that's A, half of it. So 0.3829. I have to halve the area of that plus, and I have to halve just this part, B, yeah? So I'm going to halve this 0.3829. 0.7887 and halving it. So if I put that on to the calculator, I will get 0.5858. And that is my answer to part A. Moving on to the part B, the arm span in meters for a group of 1,200 residents of a town are normally distributed with a mean of 1.68 meters and a standard deviation of 0.24 meters. By first calculating z-scores, use the table above, which we have on the side, to determine how many of the residents will have an arm span greater than 1.5 meters. First, we need to calculate z-scores and then use the table to convert it, the z-score, to probability to find how many residents have an arm span greater than 1.5 meters. So let's collect all the information it's given to us. First, I'm going to call the population as an N, 1,200, mean, which is the mu, we call it, mu here, 1.68. And then we have sigma, the standard deviation, 0.24. These are the given one. And also, x is given 1.5 meters. So first step we have to do is find the z-score. Now I'm going to write a formula for this. It's x minus mu over sigma, which is 1.5 minus 1.68 divided by 0.24. Now this z-score is 4 when x equals 1.5. When you put that in your calculator, you get minus 0.75. That's my z-score. So in my bell curve, minus 0.75 and 0.75. So we are looking at these areas, which is here. That's 0.5467. Use the table, we convert it to the probability, the area. So to find how many residents will have an arm span greater than 1.5 meters, we need to find the probability that is bigger than negative 0.75, which is from here all the way to here. Okay, so that's the when x equals 1.5. So we want to know all the way from minus 0.5 in z-score to the end. Now we got the area for up to here. Yeah, that's a 0.5467. So how are we going to find this area? The bell curve total area is 1 because of the probability. You can't have more than 1. Now, we do have the middle section. If I take that away, which is 0.5467, I've got left with this section and this part, okay? Because they're symmetrical. So when I take away the middle part, I got two symmetrical, again, the same area each end. I'm just gonna halve those. So what I'm gonna do is here, probability that z-score is bigger than negative 0.75, which means we are getting a probability or area of arm span is greater than 1.5 meters. And what I'm gonna do is I'm gonna do 0.5467 plus, that's this part, big chunk of it, and plus the n bit, which is this one. I'm gonna put that in here. I put all that in my calculator. I will get 0.77335. Now that is just my probability of people whose arm span is greater than 1.5. Now that doesn't give me how many people are in that. have to times by the population, 1200, and that'll give me 928.02 something something, and roughly 928 people, residents, will have the arm span greater than 1.5 meters. So that's my answer. Okay, well, that's it really. Hope it helped. See ya.